Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Odyssey x86 J4105 single board computer, which has been supplied for review by my friends at Seeed Studio. As the name implies, this is an x86 based SBC that can run Windows and x86 based Linux distributions, and it's also got amazing connectivity. So let's go and take a closer look. Right, here we have the Odyssey x86 J4105 in its rather nice box. I do like the packaging here, matte laminate on a very nice box, all the specs there. It's always good to see a board which is nicely presented by its manufacturer. And before we open this thing up, it's worth pointing out there are three different versions of the Odyssey x86 J4105. Firstly, there is the x86 J4105 800, which has 8GB of RAM and no onboard storage. Secondly, there's the x86 J4105 864, which has 8GB of RAM and 64GB of onboard flash storage. And on this board, Windows 10 Enterprise is pre-installed, but it's not activated. Finally, there's the x86 J4105 864 with Windows 10 Enterprise activated, which, as you would imagine, has 8GB of RAM and 64GB of onboard flash storage, containing an activated version of Windows 10 Enterprise. And I believe this is the version of the board we're looking at here. You do, of course, I'm sure, also want to know the prices, and here they are, with the board without eMMC costing $188, and the board with eMMC but without Windows 10 activated costing $218, and the board with eMMC and Windows 10 Enterprise activated costing $258. So with all of this clear, let's now open up the box, which I think is nice and straightforward. Yes, it just slides like that to take the outer thing away like that, and put it over there, all of which lovely in silver. I do like the attention to detail on the box, and aha, we've got a manual. There we are, which is, I'm sure we'll look at some point. There it is. This is the board, 110mm square, I think. Beautiful looking thing. But we'll obviously look at that in more detail in a second. Quite heavy, a big heatsink on the base of the board. What else is in the box though? We better look at all the other bits first. What else is in here? Oh, lots of things. This must lift out, I presume. Oh, it does. Oh, come on, come on. It's like opening up a very complicated something. There we are. What's in here? There's a bag, rustling things, lots of things in here. I think it's great you get everything you need in one go. There's nothing you have to buy to use this board. This is, let's have a look. This is a cable, as you can see. This has got us excited, doesn't it? What's in here? Oh, this is a SATA cable, which of course gives you a clue to some of the connectivity on the board. There's a real-time clock battery, and that's an antenna, Wi-Fi or Bluetooth. Another antenna here, I think, also for Wi-Fi or Bluetooth. So we've got various cables we can use with the board. This, I'm pretty certain, therefore, is the mains adapter. It comes with a universal adapter, I think. We open this up as well, get in there. No need for Mr. Scissors or Stanley the knife today. There we are, universal adapter, and I imagine, therefore, here we've got these must be the things to plug onto there to turn this into the appropriate sockets. There they are. We've got UK and US and all the stuff. I need this particular one, which will go onto here, I'm sure, to make it into a UK actual adapter. Anyway, there's all the different bits we get in the box, but of course what you really want to see is the board itself. So let's bring that back into view. There's the actual computer, and let's take a closer look at it. And one of the first things you may notice is it's actually labelled Recomputer Alpha, which apparently all of the first batch of Odyssey x86 boards are labelled that. The rest will be labelled Odyssey x86 J4105. So let's turn to the specs of the board, and to do that really we should turn it over because the processor is underneath, beneath this rather larger heatsink and fan. And it's worth pointing out that if you get the board without eMMC flash storage, you don't get the fan, whereas if you get the one with eMMC flash storage, you get the fan and the heatsink. And beneath the heatsink, and I'm not going to take it all off to show you, but beneath here is the processor, and the processor is an Intel Celeron J4105, which is a quad-core processor with a 1.5 GHz base frequency, which bursts up to a 2.5 GHz. and it's also got Intel UHD 600 onboard graphics. And my guess is that the RAM is also sitting under this heatsink somewhere, and the RAM, as I've said before, is 8 GB. It's 8 GB of LPDDR4 RAM. If we turn the board back over the other way around, let's come back to the top of it. We can see various features here. For a start, here is the eMMC flash storage, which is a 64 GB SanDisk chip, eMMC version 5.1. Next to this chip, we find the first of two M.2 slots on the board. We've got one here, one over there. And this first M.2 connector is a B-keyed, so it can take a SATA SSD, as you can see, would fit in there, or it can take a cellular module, as you can see also written on the board. I'll say a bit more about the cellular module in a second. And then the second M.2 connector is here. This is M-keyed. This can take an NVMe SSD, and it's a PCIe x4, so it'll be nice and fast. Also on the top of the board, we've got the wireless module, which you can see here. This gives us a 802.11 ABGN and AC Wi-Fi and a Bluetooth 5.0. And as you can see, it's also got the antenna connectors to connect on those antennas we saw earlier. Finally, on the top of the board, I'll point out the connector here, which is for the real-time clock battery. Turning to the front edge, we first find a power switch, although if you want to add your own power switch, there's a header for that just behind the switch. And then next to that, we've got a barrel jack for power for taking 12 volts from the supplied mains adapter. Next to that, we've got count them, 2 gigabit Ethernet ports. I'm sure that'll get some of you very excited indeed. And these have got Intel i211AT PCIe controllers. Next to that, we've got a vertically mounted full-size HDMI socket, which offers a 4K output at up to 60 frames a second. And then finally on this edge, we've got 2 Type A USB 2.0 ports. Rotating around, we find a standard SATA connector. This is SATA 3, and next to this, we've got 3 ports which give us SATA power. So this board is well equipped to add a SATA hard drive or a SATA SSD. Spinning 90 again to the third edge, we find a 3.5mm audio jack, which offers us a stereo headphone output and a microphone input. And then we've got a USB 3.1 Type-C connector, which also offers DisplayPort 1.2 connectivity, which supports 4K output at up to 60 frames a second. And if you want, you can also power the board using this USB-C connector. Next to that, we've then got a Type A USB 3.1 connector, and then next to that, we've got a stack of slots. This is, I think, rather interesting because on the top here, we've got a microSD card slot, but beneath it, we've got a SIM card connector for cellular connectivity. However, do note this only works if you have an M.2 4G cellular module fitted in the B-keyed M.2 slot. Finally, the fourth edge of the board is very much for makers, with lots of connectivity, as you can see. Specifically, we've got this 28-pin connector, which is connected to an onboard Arduino ATSAMD21G18 microcontroller. And then along from this, we've got a 40-pin Raspberry Pi compatible GPIO header. So if you want to do IoT, robotics or similar projects with this board, it's very well equipped indeed. And so there we have it, the Odyssey x86 J4105, a very interesting new single board computer. And if you're wondering about a case, Seeed Studio have a fantastic enclosure about to hit the market for $14.90, as we can see here on their website. Sadly, the state of the world right now has prevented me from getting hold of a case to show you in the flesh, in the plastic as it were, in this video, but they are sending me a case and I'll therefore be fitting the board in that case, in the enclosure, where I do a project with this board in a future video. Right, I've now got the board connected up. As you can see, I've connected in mouse and keyboard by USB 2 and HDMI for our video output. And I thought I'd use one of the Ethernet connectors for getting online. It seemed unfair not to do that. And of course the power is in there. And I've also fitted the real-time clock battery into the connector on the top of the board. And as you can probably see, I've also fitted some standoffs. I had these lying around. These are 20mm M3 standoffs, which work very well just to raise this board off the surface here, just to stop it getting damaged as we boot it up. So let's press the switch. And here we are booting up Seeed Studio, the IoT hardware enabler, and going into Windows now. This is not my first boot, it's my second boot. I've just gone in and changed the screen scaling a bit so we can see things better on video. But other than that, this is exactly what you get if you've got a Windows 10 Enterprise pre-installed on the eMMC on the board. And it seems to be going to Windows pretty quickly. Welcome, it says. I don't like the blurry effect they have on Windows now. Anyway, there we are. That was a pretty rapid boot into Windows from the onboard eMMC flash storage. And if we just have a look at how much storage we've got left on that storage, let's open that up and go to this PC. And you'll see about half of it is used, 31.5 gigabyte free out of 57. So just under half is used with the install of Windows 10 Enterprise if you choose to keep that. But of course, many people, I guess, will install other things on this board. Let's just look at the menu, just show it it's nice and responsive. This is a very, very responsive version of Windows 10. This board is perfectly powerful enough to do all kinds of things many people want to do with a computer, isn't it? Let's just launch the browser. I'm going to go into Microsoft Edge. That's a bit bad, isn't it? It works with the world's favourite website, as you can see. We'll have to add this board to my list of single board computers, won't we? It'll go in somewhere down here if I can learn how to use a web browser. And I'm sure some of you will ask, can it play YouTube videos? Of course it can play YouTube videos. It's a powerful x86 board, but we will just try it out nonetheless. I would point out that right now my internet speed is horrible because so many people are working from home. So this is not the board's fault it's taking so long to buffer, but just because so many people are using internet. Let me find Stats for Nerds. Where am I? I'll get there in a second. There we are. Stats for Nerds coming up down there, and it has dropped a couple of frames, probably due to the buffering, but you know, this does not look like a board having any problem whatsoever playing back at HD YouTube. This looks perfectly good to me. So that's what I would expect. The board is working very nicely. I think I'll now move on and we'll do some more detailed tests. Greetings. Here I am back again, and as you might have noticed down here, Windows does want activating on this board. This is clearly the version of the board that comes without Windows 10 Enterprise activated, but this won't stop us running some tests. And if I do keep Windows 10 on this board on the eMMC, I'm sure I'll use Windows 10 Home rather than buying an Enterprise license. Anyway, let's run some tests. So I've installed here a Crystal Disk Mark, and first of all I thought we'd test the speed of the internal flash storage, which is the C drive here. So let's run the tests. And there they are, they finished, and these are pretty respectable for internal eMMC. What 277 megabytes a second read and 142 write as the headlines here. Clearly not the speed of a standard SSD, but not bad for internal eMMC. I've also, when you weren't looking, installed this WD Black NVMe SSD onto the board, so we can test the speed of that as well, just to see how fast the interface is here. So we'll pick that one up here, which is there our D drive. The E drive is a USB drive plugged into this machine. So let's test the speed of the NVMe SSD plugged into this board. And there we are again. We've got our results, and focusing once again on just a headline maximum read and write speeds. We can see these figures are impressive, certainly much faster than you get from a SATA drive, 946 megabytes a second read and 884 write. This said, when I tested the same drive on an i7 PC a while back, I got a speed of a 3447 and 2538. So clearly the interface here is not allowing the drive to reach its maximum potential, but still these are good results. Let's also run a Passmark, which I've got running down here, and you can see Passmark is running along, and it's also reporting our CPU temperature is currently about just jumped there, 46 degrees. It thinks our current CPU temperature is 47 now, and I suppose it's doing a 3D animation there. And I should just point out the fan in this board is pretty quiet, and it's one of these fans that doesn't speed up and slow down. It's either on or it's off. Right now it's on. You might just be able to hear it in the background. Possibly not, but when the fan is on, you can't hear it very much. When the fan is off, obviously the whole board is silent. Anyway, let's run through the Passmark tests. We'll kick them off over here and press run. There we are, we'll run all the tests. And this will take a while, and I should point out that the disk mark part of this test will be based on the internal eMMC flash storage. And here we are starting the 3D graphics tests. We're getting what about 20 something, 21, 22 frames a second, down to 18 with these aeroplanes flying around. But the water looks pretty with the sunlight reflected in it, doesn't it? And now we're spinning around these floating islands, which are clearly going to really stress a board like this. It's not designed to do this type of graphics, but it's managing about 4 frames a second. We've got to give it its due. It's making pretty pictures still. And now we've got to the famed floating jellyfish in space test, which is it's going along, isn't it? Oh, there's a big planet there. I wonder where it is. I wonder if there's people on that planet who watch videos on YouTube. Oh, and finally we're off into the space battle. It's good to see this board will run all of the pass mark tests, so it must have a reasonably modern and appropriate graphics for that. This is clearly not a massively impressive result, but I'm sure this board will be great for retro gaming. And there we are, it's finished. We've got our pass mark result. I don't think I'm going to submit my baseline at this stage though online. We'll just say OK to that. And if we just view our results, I can never remember where you get hold of these. There they are. There's the results in for the whole lot. And you can see this computer getting a score of 1361 for its overall pass mark score. And that is a little bit faster than a Latte Panda Delta. In fact, quite a lot faster than Latte Panda Delta, which is a similarly priced x86 based single board computer on a 1031. And just to give you an idea, it's not as fast as you wouldn't expect it to be as a Ryzen 3 2200 GPC with a similar amount of RAM. And I'll just flick down the other benchmarks here so you can see them if you wish to stop the video and have a look at those. You can see there they are. But overall, I'm pretty impressed with how this machine has performed. And a final thing I want to say is that during this test, a fan has been coming on, and I've now decided that maybe the fan does run at multiple speeds. It seems to have a higher speed and a lower speed, as well as being turned off. Right, here I am back again, and I press the delete key on boot to enter the BIOS. And on the first screen we see all the basic information about the board, including the fact the memory runs at 2133 MHz. And if I move across to the next tab, you'll see there's lots and lots of options here. There's even a TPM module on this board, lots of things we can change and configure, which is not unusual on a general computer, but on an SBC, it's great to have all these options available. And in fact, there's even this option here for configuring the GPIO pins, the Raspberry Pi compatible pins on this board. I've not seen that before in a general BIOS. We've also got chipset options. We can, for example, change the onboard graphics aperture up to 0.5 GB if we wish, security options, boot options as you would expect. And talking of boot options, as you can notice there, I've actually installed Linux on this machine. I've actually installed Linux Mint on the NVMe SSD. And I've left the board to boot from Windows by default, but if we just override that now and launch Linux Mint, there we are. I thought you might want to see Linux running on this machine. It's Linux Mint 19.2 because I had that ISO available, but it shows us the board running Linux Mint perfectly well. And I would point out I've taken out the Ethernet lead and we're using a Wi-Fi here to go online because I wanted to check that the Wi-Fi drivers would work with this board in Linux Mint, and they do. As you can see down here, Wi-Fi is working fine, as is Bluetooth as well. That's cool. And Linux is working very nicely on this board, just as Windows did. And as a test, I've installed Kdenlive. I thought, can we video edit on this PC? And the answer is yes, we can. Let's just open up an edit. This is the edit from my Pi 4-week video from a few videos back, where everything we edited in Kdenlive on a Raspberry Pi, but we can look at it here as well on this Odyssey x86 board, and it plays perfectly well. It's very, very fluid. We can go back and forth. There's been no problems at all editing on this board. And whilst I've not edited this particular video on the Odyssey x86 J4105, it's certainly something I could have done. As you probably gathered, I'm very impressed with the Odyssey x86 J4105. In particular, I think that Seeed Studio have managed to bring in the board at a reasonable price point for what you get. And in this context, it's worth reflecting on the fact that any manufacturer that decides to make a new x86-based single board computer has got a difficult trade-off to make between the capabilities of the board and the price of the board. Because the problem is the cost of a component for an x86-based SBC are significantly higher than for an ARM-based board like a Raspberry Pi. Particularly the processor is going to cost a lot more, whether it comes from Intel or AMD. And as you'll know if you've been watching this channel for a while, we've seen some new x86-based boards coming to market in recent years which have been really, really good boards, but they've cost at least twice as much as the Odyssey models, and that's put them out of the price range of many people. And therefore it's great to see the Odyssey board starting at $188, going up to about $250-ish if you include Windows. So it's a really good price point. And even when you've added in a case, and I can't wait to see the case for about $15 fairly soon, you've got a board which is significantly cheaper than, for example, an Intel NUC in roughly the same form factor with all sorts of potential applications. Talking of potential applications, I've been planning for some time to make a video on FreeNAS, and I'll therefore be using the Odyssey x86 J4105 as a FreeNAS board in a video fairly soon. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.